Okay, this is 7.5a, and the name of this section is Determinants and Cramer's Rule. Now, this section is always a hard one for me to teach simply because you learned how to use matrices to solve systems of equations, and gosh, at first they were very, very complicated, and then we went to the a minus 1 times c equals x, and that helped us find x, y, and z by taking the inverse of a, multiplying it by c, and getting x, and you're like, okay, that's easier. Well, 7.5 is one of those lessons that makes it even easier. So it's that typical, let me teach you how to do it the really, really hard way. And once you're frustrated and irritated, I'm going to show you an easy way to do the exact same thing. Welcome to 7.5, Determinants and Cramer's Rule. So this is not a hard lesson at all. You're going to find that this is a lot easier than solving systems of equations using matrices. So we're going to use what are called determinants. And then once we learn how to find the determinants of a matrix, then we're going to use Cramer's Rule, which uses the determinants. Okay, so determinants are pretty easy. It is basically, well, let me just show you the one they give you from the book. I hate it when they just show you letters because it seems like it makes it more difficult, but I think in this instance it'll be fine. So there's our matrix. Our determinant of our matrix is taking A times D minus B times C. Okay, and so what that looks like is, let me highlight, A times D, and then we subtract B times C. And that's our determinant. Okay, and determinants are done differently than matrices. I mean, they look differently. So if I ask you to tell me the determinant of a matrix, you will first of all put it in determinant form. And determinant form, all it does is it makes this symbol a straight line instead of a bracket like that. It just makes it two straight lines. And that means basically find the determinant. All right, so let's do a little bit of practice here before we get into some actual stuff here using Cramer's Rule. So we're given 2 and 4, negative 1, negative 4, and the question is find the determinants. So the determinant, if for finding the determinant, you've just got your vertical line, do that first, and then you multiply those two, and I would suggest putting things in parentheses, and then this way. The only reason I do that is because this doggone negative sign, sometimes you get negatives in here and you don't know if you're supposed to have them or not, and this way it kind of keeps everything orderly. Negative 8 minus negative 4, which is negative 8, plus 4 equals negative 4. So the determinant of this is 4. And again, we're going to be using determinants a lot, so it's always good practice to try these out. Let's just do one more. Negative 3, 2, negative 1, 4. Determinant, I would suggest you write what I am doing right now. Then negative 3 times 4 minus 2 times, obviously it doesn't matter what order you multiply negative 1 times 2 or 2 times negative 1. And there's my determinant for that matrix right there. Okay, so this determinant is for a 2 by 2 matrix. Okay, very, very important that you learn that this is how you do your determinant for a 2 by 2, because later we're going to do a 3 by 3, and obviously you're not going to have the diagonals the same, so it's going to be completely different. But if you get used to the 2 by 2, then the 3 by 3 is pretty painless. Again, it's just remembering the steps, and since you're allowed to use your notes on a test, then I would suggest you write down the steps and have a couple examples there to remember how to do this. Okay, so one of the things that's really, really important when you're doing these kind of problems is you have to have a square matrix. Okay, a 2 by 2, 3 by 3, 4 by 4, etc. Okay, it can't be like a 2 by 3 or a 3 by 6 or something like that. It has to be a square matrix. And this 2 by 2, since we have 2 columns and 2 rows, it works on a system of equations that has 2 equations and 2 variables. So, for example, I'm going to skip the Cramer's rule on the bottom and just go right into explaining what it is here shortly. But we have this system of equations that's 2 equations and 2 variables, and we can use Cramer's rule in order to solve that. Okay, so there are a couple different parts to Cramer's rule, and we'll get into what those parts are right now. Okay, so Cramer's rule looks like this. To find x, you take the determinant of x over the determinant. To find y, you take the determinant of y over the determinant. Okay, so if you find this, that'll give you x. Find this, that'll give you y. Okay, so knowing that, what the heck is the d subscript x, the d subscript y, and the d? All right, so let's look at the green box on page 564, why my brain didn't wrap around that whole box thing. And let's look at what these d's are. All right, so according to the box, we've got a system of equations that looks like this. And I would highly suggest you write this down. So there's my system of equations. All right, the x and the y are my variables. The a, b, c, d, u, and w are all numbers. Okay, and we'll put some numbers in there later, but for right now, that's what those are. Okay, so d of x, or however you want to say that, d subscript x equals the determinant u, w, b, d. Okay, that's all it is. So whatever number is u, we're going to put there. W goes there. B goes there. D goes there. Same thing with d of y. That is going to equal a, c, u, w. Okay, nothing weird, but and then we're going to find the determinant. Remember how we did that? We multiplied that times that, subtracted that times that. Okay, and then finally the d. Do that in black here. So the d is a, b, c, d. Okay, so what we have is pretty nice. We've got that there, and that there. Okay, which there's our d of x up here. So whatever number we get here, we put there. Whatever number we get here goes down here. Our d of y here is up here, and our d is from over here. So it's pretty simple to be able to use that. Okay, so let's move all of this stuff kind of up and out of the way here and actually do one of these. If I can find my stuff here. Oh, there it is. Bring that back there. Okay, make this a little bit smaller and move it over here. And then I'm going to move this up here. It's pretty cool. I can do all that, huh? All right. So this is example 2. X minus 2. Whoops, I need to use a different color. All right. X minus 2y equals 5. 5x minus y equals negative 2. There's my system. Okay? It's a 2 by 2 because I've got 2 variables and 2 equations. So it's exactly what I need. All right, so now we need to evaluate 3 determinants. We need to evaluate D. And D is going to be, remember it was A, B, C, D. Okay, and that means that we are going to evaluate 1, negative 2, 5, negative 1. Okay, so that's my first determinant. So 1 times negative 1 minus negative 2 times 5 gives me negative 1 plus 10 equals 9. Okay, so my D equals 9. And I don't need any of this junk anymore. So we're going to get rid of this because we found out our D is 9. All right, now we're going to find out what our D of X is. And it's going to be UW. It's this one here, UW. So my 2 answers. And then BD, which is my Y's. So that gives me 5 times negative 1 minus negative 2 times negative 2. So negative 5 minus 4 equals negative 9. So my D of X equals negative 9. And again, I don't need this stuff anymore. I already found what the D subscript X is, the determinant of X. Now I'm going to find my determinant of Y, which is going to be AC. So 1, 5, and then 5, negative 2. So 1, negative 2, minus 5 times 5. So negative 2 minus 25 equals negative 27. So my dy equals negative 27. Okay, that's as hard as it gets for a 2 by 2. 3 by 3 gets a little bit more complicated, but not really any harder. Okay, so here we go. My x equals whatever number I get for that over that, which in this case is d of x negative 9 over d equals negative 1. Okay, so I'm just using this stuff here. All right, my y value equals, and my y is negative 27. My d was 9, so that gives me a negative 3. And that's all I need. I'm looking for my x and my y. So, system of equations, instead of going through all that matrix stuff, multiplying it by or getting the inverse and multiplying it by c to get our x and our y, that's all we do. That's what Kramer's rule looks like. So my solution set for that is negative 1, negative 3. So that is the answer to that system. Okay, whoever invented this stuff, I don't know if it was actually a guy named Kramer or not, but he's a freaking genius to come up with this crazy stuff that works. Okay, so that is a 2 by 2. They all work that way. I'm not going to do another example because they're all the same. All right, so the next part of this is going into a 3 by 3, and I will start a new video for that.